I'd like to thank the organizers for the Bellini and Bloody Mary bar. It makes this talk a lot more entertaining. My name's Jason. I'm here with my co-founder, Jeff McComb, and our third co-founder, Dr. Katerina Riga. We are Lisi Global. We're an ag tech company based in Richland, Washington. We've designed, developed, and patented a technology to manage very important soil pests without the use of chemicals by applying electricity directly to the soil. If you don't know what a nematode is, don't feel bad, but it's a $350 billion a year pest in crop losses. $17 billion of toxic chemicals come into our environment every year to manage these pests. And as the toxic chemistry gets phased out because it's harmful, the new chemistry that's available is much less effective. That leaves the grower with a lot fewer options. Our solution is the directed energy system. It's born out of imaging technology that Jeff and I work with every day in our imaging company. We got the idea to apply these pulses of energy directly to the soil. So we figured we'd try it. We built a prototype. We tested it with Dr. Riga. It worked. Prototype after prototype, hundreds of experiments, it worked. So we took the prototype to the USDA and Corvallis. They validated that, in fact, this technology does what it's supposed to, and it eradicates these very difficult to manage soil pests. We took all that information, applied for our patent. That was granted in 2018. We're building our first commercial unit to deploy into our first cropping system. It'll be by the end of this year. We'll be at revenue. And that cropping system is golf courses. They have a huge problem with nematodes and turf. They create these brown spots, difficult to play on. They put $100 million of chemistry a year into our soils trying to manage these pests, and they're not having very good luck. We're going to deliver this through a cropping system that they're used to using, a turf aerator. We take our electronic technology, we made it to this aerator, we deliver it to the soil, and it manages the pests without having to change what they do on a daily basis. Initially, we're going to deliver this service as a fee-for-service. We're then going to take the equipment, lease it to a channel partner, and let them deliver the service. That revenue stream will allow us to develop this technology into other cropping systems. More importantly, it'll allow us to develop our 13 other areas of IP that's coming under our portfolio. And really, I want to stress that we are not a service delivery company. We are an ag tech company. The implications of this technology is huge. We've got really two. One is to displace $17 billion worth of harmful chemistry, and two, increase the global food supply by up to 15%. So I invite you to come along with us on this journey, and thank you very much for your time this afternoon.
Thanks, Jason. So tell us a little bit about how often someone would have to zap nematodes in the grass of golf courses in order to keep a golf course green.
Well, it depends on how well the nematode was born. If he was born in Nebraska, we only get at him once because they have this hard winter, and it really naturally suppresses the population. If he was lucky enough to be in South Florida, where they don't have winter, it can be 2 to 3 treatments a year because the population never dies off naturally.
And how does that compare to pesticide application?
Almost the same, except for instance, this year, one of the reasons that we're going into turf is because a product that they've been using that has proven effective in the past, for whatever reason, the chemistry doesn't work this year. And so in South Florida and southern Georgia, they're having a huge issue. They've reached their limit on how much of this they can put in the ground, and it's not the end of the year yet. So
that's gross. Questions from the audience? Yep.
Hi, thank you for the presentation, by the way. So my question is, so you send electrical pulses through to these nematodes, right? How would that affect other organisms, ecosystems? You don't want to be hurting other things that may be beneficial.
Absolutely, absolutely. Probably a good third of our research has been around developing this technology so it's as selective as possible. A few reasons why. One, it's a direct impact to our cost of goods sold bottom line. The more we can target it to the pests that we're looking at, the less it costs us to deliver the service. Also, the physics of the cropping system, the electrical characteristics of the soil compared to the electrical characteristics of the plant root itself are so dramatically different that we can have a non-lethal dose for organisms out in the soil, but because that root concentrates that energy, and that's where the pest's at that we're trying to address, that dose is lethal there. And so it makes it very, very selective. Plus there's some other more nerdy neurological talk that I could go into, but let's just say that 30% of our work has really been around keeping the beneficials in place, and that's something that the chemistry doesn't do. Most of the chemistry is very broad spectrum, it's very non-selective. It has a lot of constituents that are persistent in the soil for weeks or months. We're a treatment that comes in and we're done, and that really allows the ecosystem to try and balance and revive in a more natural state.
Hi, so you mentioned nematodes specifically. What other pests are you trying to target then? Or are you trying to target any others?
We've done a lot of work in another pathogen. It's various types of soil fungus, Phytophthora and verticillium specifically. They're huge issues for small berry fruits and actually for most cropping systems. And it's a fungal pathogen. We've got a paper right now that's in review that includes 4 different species of nematodes and 2 different fungal pathogens that we've been able to address using this technology. We've also branched it out into insects with a soil-borne phase, small microvertebrates. I mean, there's an entire swath of pests that are in the soil that we can selectively target.
Somewhat of a nerd question. What is the nature of what you're scientifically calling a zap? And is this a sonic signal? Is this an electrical signal? Does it depend on the soil moisture, et cetera? The nature of the soil, alkaline, acidic, and so forth?
Yeah, so certainly the soil physics and the soil condition at the time has an effect on the electrical characteristics of the soil. What's been unique and what's allowed us to bring this idea to market, where it's not really that unique of an idea, they've been trying to do it for a long time, is the technology that we're used to dealing with in imaging creates very high energy, very short duration pulses. The hardware for that has only been available, especially the way that we're doing it, in literally the last few years. Our expertise in that area allows us to develop that signal, and it's typically more of a square wave pulse than a sinusoidal. We deliver a very high intense pulse in a very short duration, with a lot of control, and then obviously the soil physics matter, but that matters in the chemistry applications as well. The farmers are used to working around the environmental conditions to apply these treatments, and we're just going to fall right into that exact same cropping practice.
Good afternoon, or morning, I guess still. Question is regarding this service delivery to the golf course community. Are you trying to find someone to help you get the partnership to get the courses on board? Are you just looking for money to produce more units to push out? Where is your status of your company and what are you seeking?
Sure. We've signed an agreement with MD Plant Health Solutions in the Southeast. They are a service delivery provider that's a broad spectrum. It's from seed to irrigation to pest management, soil nutrition. We've signed an agreement with them to distribute this, to get us in front of their 700 golf courses that are in Florida and Georgia. And they've identified the first 30 or 40 that are in a gale force panic right now because their current practices are failing. But that's the situation that we're in right now. We've signed that first agreement. We'll go down and deliver those services as a fee for service and then hand that service delivery model off to them, provide them the equipment and the training, and then we'll branch out into other partnerships as they become apparent. But those 700 golf courses in Florida should keep us busy for the next year or so.
Jason, how do we know that it's working? How do you know that the technology
There's
is
a lot of
working?
assays, so this is where Dr. Riga comes in, and I wish she was here. She's really good at this. There's a lot of assays that you can run that they run with current chemical nematicides that give you a really good indication with a very standardized test, and this is what the USDA did as well. Very standardized test is how this works. In golf courses, when you put it in the turf is brown. You come back 2 days later, and the turf is green. It's really just a symptomatic treatment at that point. We could do soil samples and collect counts and do all of that, but if it turns green, we know we've got them. So.
Awesome. Okay, thank you.
Great. Thank you.